Before we get into chapter 6 with exponents, we're going to look at properties of multiplication and division of exponents. And one of the properties that we begin with is the property with the product of powers. Looking at the property, we see that numbers with the same base multiplied together, we take the exponents and add them. The simple theory behind this is that a to the fourth represents 4a's being multiplied together here and 3a's being multiplied together here. As long as everything is multiplied, you can see that we have our 4a's here and our 3a's here. Multiply them all together, you're essentially just adding the exponent to get your exponent of 7. Take that example and let's look at some more. To expand this here, you would say this is m times m times m, and the expanded version would be m times m times m, which essentially adds up to m cubed. Take a look at the next few. Y to the fourth, y to the 10th, as long as they have the same base, your answer as the simplified version. And again, once you get used to the property, you don't need to show the expanded version, but the simplified version would be y to the 14th power. Try to do the next few on your own. As you see the answers over here, the common mistake that people make here is that they would multiply the 6 and the 6 to make it 36 to the fourth, but we keep the base the same and just make the exponent 4 by adding the 2. Don't forget over here for this 3 base that the 1 is an exponent for the first factor. Because the negatives are in parentheses for the 4's, we're going to keep the negative as we roll to the other side in the simplified version. If this were an even exponent, we might think about taking away the negative, because any negative number raised to an odd power would make that number positive anyway. Down the bottom here, we don't have similar bases, so we're just going to keep the factors the same, and the expression remains exactly as it started. The second power of exponents as we multiply is when we have a power raised to another power. In this case, a to the fourth is being raised to the third power. The expanded version of this looks like a to the fourth times a to the fourth times a to the fourth, and in the previous property when we had a to the fourth and the base was the same, we just simply add the exponent. So this is a continuation of the applied power property from before. 4 plus 4 plus 4 gives us 12. Essentially what we're going to do is we're going to distribute loosely this exponent into any factor inside the parentheses. So 3 times 4 gives us 12. There's some tricks to this as we move forward into some other examples. Using that property, take a second, hit pause, and answer these simplified questions to see if you can come up with an answer using the power of power property. Here are the answers to those simplified expressions. Keeping in mind down the bottom here, we have negative y squared. If the negative is in parentheses, we do actually count that as a factor, and so it's actually negative 1y. The 2 would get distributed to the negative 1 and to the y, which is why the y becomes positive in the answer. The second one here, we take this 3, again, because it's negative 1y. Negative 1 to the third power gives us a negative value, and the 3 also gets distributed to the y, making this negative y cubed. As I mentioned before, when you have a power raised to a power, we can take this exponent right here and we can actually distribute it to each factor inside the parentheses, regardless of the base. So here you see there's 2 different ways that we're going to actually simplify this expression. The first way is to distribute the 2 to each factor in the parentheses. 5 times 2 is 10, 4 times 2 is 8, and then we use the power of multiplying to add the exponents to get 18. The second example would be to first add the exponents together because of the common base, After we do that, we're going to distribute this exponent in. 9 times 2 also gives you 18. Two different ways to do the same simplifying. Here are some examples looking at other complicated ways to simplify exponents and expressions with exponents. Here we're going to look at the 3 and the 2 that's negative, and we're going to distribute in this 2 to the 3, and we're actually going to make this answer negative 2 to the 6th, which, because the exponent is even, negates the negative sign here, because an even number of negatives makes a positive value, so we can take away that negative and just make it 2 to the 6th. Take a look at a few more, hit pause, and try to solve and simplify these complicated expressions. Here are your simplified answers for those. Take a note of any ones that you may have messed up or you have questions about. Bring them into class so we can discuss them at the next session. Let's move on to division. Properties of division when it comes to exponents are common sense as it applies to the multiplication properties of exponents. Take a look at the first property. In multiplication, when we were multiplying, we took the same base, multiplied them together, and added the exponents. In this case, because we're dividing with the same base, we're going to take the same base, the two exponents, and we're going to simply subtract them. 5 minus 3 gives us a final answer of 2. Let's take a look. We can combine these two because they have the same base, and instead of it being a like in the example from the beginning, we have a squared because 7 minus 5 gives us 2. In the second example here, we're going to combine the bases and the exponents in the top to give us a numerator of 8 to the 6th, and then we have a denominator of 8 to the 3rd. We can use that property of subtraction with the exponents to give us a final answer of 8 cubed. Here are 3 examples that I'd like you to try on your own. Here are your answers for those. Notice in the middle we have a negative exponent. In our first lesson of 6.1, we will discuss what negative exponents look like as they pertain to simplifying expressions. The second property is the quotient property, which uses an exponent on the outside of a quantity, and we're going to use the same idea of distribution, but instead of distributing to each factor, we're actually going to distribute this squared to both the numerator and denominator of the fraction, and finally give us a simplified version of 4 squared divided by 5 squared. Here are some examples. Taking a look here, we do not have common bases. However, we have an exponent on the outside. Looking at this, we're seeing that anything on the inside that could be simplified already, we're going to simplify first and then distribute the exponent. Because the quantity inside the parentheses cannot be simplified, we're going to simply take this exponent and distribute it to each factor, the 7, the a, and the b, all together using multiplication. Your simplified version there is going to be 7 cubed times a cubed, and then the denominator is going to be b to the 6th. Take some time and try to simplify these two expressions on your own. Here are the simplified answers for the 2 remaining expressions. To prove that you watched this video, I'd like you to try 2 challenges. Take a second, copy them down, and in class, please bring them in simplified so that we can discuss the answers to prove that you understand this concept. Here's the first one. And here's the second one.